In this section, we'll look at document tokenization. So the idea of tokenization is that we're starting off with an input document, which is a sequence of characters, and what we want to do is cut it into a sequence of tokens. So here in this example, we've cutting out certain stuff altogether, like the punctuation marks, and then the rest of it is coming out as a sequence of 4 tokens: friends, Romans, countrymen. That's going away as well. So a token is an instance of a sequence of characters in a document. So the point is there that if this had gone on and had said "and me," that we've got one token of the word "and" here, and we've got another token of the word "and" there. So each token will be a candidate for putting into our information retrieval system index, but commonly that will happen after some further processing has taken place, which we'll describe in the next segment. But before we get to that, the question is, what are the valid tokens for our system to admit? There are a number of issues as to how exactly to do tokenization into things that look roughly like words. So let's consider this case here. So we've just got here Finland's capital, but focusing on the beginning here, how should we tokenize it? Well, one possibility is that we replace all non-letter characters by space, and then we'll get 2 tokens, a Finland token and an S token. Another possibility is when you have things like apostrophes in the middle of the word, you delete them altogether, and then you'll get 1 token that's Finland's. Or you could decide that those kind of apostrophes, you just want to keep them, and then you'll get 1 token, but it'll be Finland's. And systems differ in the way that they treat these kinds of things. But note that if you take these choices, you're not going to get an easy matching between Finland's and just the word Finland. Let's do a couple of other cases of the complications that emerge. So a common complication in English is you get these hyphenated terms. And it seems like those hyphenated terms are on a spectrum. Sometimes you get them in phrases like state of the art with hyphens in between, where it just seems clear that you want to split on those hyphens and treat this for indexing as 4 words. The word state of the art. But there are other cases that are much less clear. So for example, when you get a hyphen in something like coeducation, it seems like it's not so clear that you want to separate that out into co and education. And what's especially tricky is you notice that there's often variation as to how people use hyphens, no hyphen, or separate into words. So you can find all 3 of these forms. Lowercase is just 1 word, lowercase hyphenated, and lowercase as 2 words. So it'd really be most beneficial to our users if all of those could be indexed together, so searching on one would find the others. And that's something we'll talk more about in the next chunk. When we're talking about having a user use a search engine, it can be effective to get the user to put in possible hyphens, because that makes it easy for you to say that if the user types in lowercase, that then you could generate automatically to also search on lowercase with no hyphen and lowercase with a space. But the problem is often our users won't be that cooperative and will want things to work anyway. Here's another complex case without hyphens. Something like San Francisco or other similar names like Santa Monica, San Diego. Conceptually, they sort of feel like they should be 1 token because they're proper noun that's a place name, but they do have spaces in the middle of them. And so if we just have space-based tokenization, they'll become 2 tokens. There are other problems of that sort. So numbers present a lot of complications. So we both have problems such as that things that are a date might have a space in the middle, like there's a space here. but then also we'll have sequences of numbers and letters, things like PGP keys or postal codes or FedEx codes or things like that. This phone number here has got a space in it again right there. It's hard to know what we should do about all these things. Many older information retrieval systems just didn't index numbers at all, and so therefore the vast majority of this stuff just wouldn't be indexed. But that tends to actually not be very useful in modern systems. So especially if you're a programmer, you can probably think of things like when you've done searches based on looking up line numbers for when there are stack traces, or looking up error codes, which are numbers, and things like that. And so you really want to do that. On the other hand, the problem is that the space of digit sequences, let alone PGP keys, is an immense. And so if we totally index them, then the size of our vocabulary will grow without bounds. So one solution to that is we'll present later, is working on indexing subsequences of characters. A final thing that I'll note is that documents often have metadata that go along with them, the date of creation, the author of the document, and things like that. That they often also get indexed in an IR system, but separately to the main index. Now, the question of tokenization often involves language particular issues. Let's just look at a couple of examples of that. So in French, you have the various forms of le, la, and so on for the definite article the. But one of the complexities is when you have a word that begins with a vowel, it just gets recognized as L apostrophe. So it seems pretty clear here that what we want to do is tokenize after the apostrophe so that this token will be recognized as one of the forms of the word the, and this part will be the word ensemble. In particular, we'd like in a search, if the user types in ensemble, to get a reasonable match with a document that has this, which will be dependent on having recognized this part here as a separate token. And so a lot of these issues have to be worked out on a language particular basis. To give just one example of that, at least up until 2003, Google didn't handle this. So things like this l'ensemble were just indexed as a single word, and you would just lose in these kind of situations. Now, of course, 2003 is a long time ago now, but on the other hand, Google started as a commercial company about 1999. So in a way, it's kind of surprising that 4 years later, no one had yet dealt with this issue. But it shows that you just need a lot of time and people with language particular expertise to get these kind of issues right. Here's one more example. So in German, famously, what you find is that unlike English, where a compound noun, so noun compound is actually a compound noun, have spaces between the individual words of the noun compound, in German, and also in other related languages, that doesn't happen at all. So this is all written as one word, which means this compound noun, life insurance company employee. Well, it's probably not surprising to you that you get into trouble sometimes if in your IR system you index that as a single token. And so what people have found is for languages like German, you can get enormous performance boosts by employing a compound splitter, which can essentially break a big German compound into its individual component words so it looks like the English representation. That can give something like a 15% boost to a retrieval system in German. German isn't the extreme case of that. If we go on to the big East Asian languages, Chinese and Japanese, that they're written with just no spaces between words. It's just a string of characters. And so then there's this problem as to how can we divide this string of characters into separate words. And that's referred to as word segmentation. So normally the ingestion phase runs a word segmenter in such languages to allow it to then index on words like we do for other languages. Japanese has further complications of this, because as well as having no spaces between words, for historical reasons, Japanese has this interesting mix of character sets. So you have katakana, which is used mainly for loan words. So this is the fortune of Fortune 500. You then have use of Chinese characters, and then you have these characters that are used to then sort of spill out syllable at a time parts of words, hiragana. And then in modern Japanese, you then will also find Latin letters, such as in this 500k dollars. And so not only now, in just thinking about it as a word segmentation problem, this actually makes things a bit easier, because often you can segment on the boundary between the change in character sets. But in other respects, it makes things a lot harder, because the character set that the user uses to enter their query may not always be the same as the character set that the answer is expressed in. One more case. So here's an example from Arabic. Arabic sort of looks scary to look at for people who aren't used to it, but there actually are spaces between words in general that you can see in here. It's written from right to left, which in old computer systems could really create problems. Or at least it's written mostly from right to left, except when you come to things like Arabic numbers, which are then written left to right. So you're kind of starting off going right to left, then there's a little bit of left to right, then you're back to right to left, a little bit of left to right, etc. So that kind of looks very complex as a writing system, with the letters joined up with ligatures and so on. And in the old days of computing, it used to be a real mess in computing systems as well. These days, with Unicode, a lot of that complexity is actually driven out of what we deal with in an IR system. So although the presentation layer of software needs to do a lot of clever stuff to render Arabic correctly, if you look at what's in a file, what's in the file is actually the straightforward logical organization of the text, so that the characters will appear in the text in the order of start going along here and then going backwards for 1962. And so we can actually index reasonably straightforwardly in terms of what's stored in the file. Okay, a lot of details and a lot of other languages there, but I hope that that's given you at least a sense of the fact that there is just a lot of language-specific issues in tokenization that someone has to be dealing with if you're going to be offering a multilingual search engine.